I'm going to turn the floor over to him, and glad you could all come down and experience Studio D and Mr. Rupert Neve.
Well, thank you. And once again, thank you for coming, and thank you, Joel, for your hospitality. Thank you for your introduction. You know, it's always a problem when you ask an old man to start talking. He'll never stop. So you will have to signify either by walking out or falling asleep or something when you've had enough. It's hard to know where to start. I haven't got any kind of stuff to fall back on to show you, you know, that we can start a talk with some good screenshots of something or other, but I'm not a good screenshot, so that's it's hard to know where to make a start. I think it would be probably a good idea if I gave you a little background of what I've done over the years, and culminating in the 9098i console. It's been called the ultimate, but you know there's no such thing as an ultimate. This is just a step on the way. Sorry about that, Joel, but you know, you'll have to get another one in about 5 years' time.
You told me 10.
Oh, okay, all right, I'll delay it. Because we don't stand still all the time. We are finding out more and more about sound and what makes good sound, what we like listening to. And of course, what you think is good sound individually, and what somebody else thinks is good sound, and what I think is good sound, is going to be conditioned by your background, your experience, your upbringing, your taste in music, and a huge amount of stuff that is going on around you. The human decoding system that we have somewhere buried between these things that we call our ears, and we think these are the ways in which sound comes in. They are in part, but they're not entirely the only paths through which sound may access the brain. You just think, for example, of things which are totally intuitive. Think maybe of walking through a jungle during the night in some very remote area of, let us say, Africa. And you hear a sound, a twig breaking. Now you can tell, however small that sound is, where it's coming from, whether it's coming from above or behind or in front or near the ground. The directional information, which we take for granted, is there. Maybe it was primitive man who needed this kind of information about his environment for his own protection. Moreover, you could tell whether that twig was broken by some relatively small animal treading on it, or it was the heavy tread of some larger animal. And, you know, there's a wealth of information. Just imagine the scene which comes through. And if all that information could come from such slender source and such an ordinary, mundane little thing as a twig breaking somewhere, what about music, which has so much more information geared to our enjoyment? What about the musical instruments which have evolved over generations, even centuries, been adjusted, refined, perfected? So what is perfection? You know, who decided that a particular stringed instrument should sound the way it does. Okay, I'm not talking about the artificial things we do which simulate stringed or other instruments at the moment. I'm talking about the original acoustic instrument. So these things come together. It's a kind of consensus which human beings have, but not all human beings, of course, will agree. Music from different parts of the world is tastes differ, and people would have a different perspective. There are different tonic scales and so on. But it's all to do with our background, our experience. We establish a point of reference. And it's like a data bank that is built up unwittingly, and when we listen to something, we are comparing what we're hearing with that data bank. Now, if that data bank is flawed, where is our comparison? What is the worth of our comparison? My great hobby horse is that we have a couple of generations of people who've grown up brainwashed into being told that this or that or the other system is the ultimate. It is perfect. Compact disc, CD quality, you know, the way it's promoted. Good as some of it may be, it is a long, long, long way from being the ultimate, I hope. And but people believe, young people, you know, they say, okay, that's great, that's wonderful. And they don't hear what might be wrong with it. Nobody has taken them in hand to teach them. They haven't, in many cases, haven't had the experience of listening to actual live music. So the data bank is flawed. Where is that going to take us as an industry? Are we going to, when digital standards improve over the next few years and we get higher sampling rates, better bit depth, and we get to the point where it's nearly as good as analog, are we going to say, oh, for the good old days of the compact disc when it had this graunchy, zippy sound? Well, having thrown a few pebbles into the pond, I suppose I could start, you know, when, how far back should I start? At the age of about 13, I was building amplifiers. I grew up in Argentina. My parents were missionaries, and I grew up as a missionary kid. And I developed this interest in sound and in audio at a very early age. Then came World War II, and when I was old enough, I volunteered and went to England and joined His Majesty's Royal Signals. And the best I can say about that was that they didn't win the war until I got there. But I'm not sure that I had very much influence at all. After I left the army, it was a very frustrating time, by the way. One of my dreams when I was going to join the army, coming from overseas, you see, I had the privilege of being able to choose what kind of regiment to go into and all this kind of thing. So I wasn't just drafted, I could choose. And the officer who was steering me through this said, okay, what's your interest? What are your abilities? What do you want to do? So I said I wanted to go into the Royal Electrical and Mechanical Engineers and into the communications side, which I knew had some design stuff, and they were doing work which I felt I would learn a great deal from. And so he looked a bit thoughtful. He said, "You want to serve your country, my boy?" "Yes, sir." He said, "Well, I believe you are a radio operator and you're familiar with Morse code." I said, "Well, just in a small way, you know. I'd done some of this out in Argentina." He said, "Your country needs radio operators, not engineers." So I said, yes, sir. So he said, you will go to this place and report to the orderly room, and you'll sign up to join the Royal Signals as a radio operator. So gone were my ideas of getting any kind of education from the army, technically. Of course, the thing with the radio operator is that if you're a good radio operator, you're always a radio operator. If you're a really bad radio operator, they promote you and you become an officer. So I could not be a bad enough one to get promoted, but I was never very good either. Then, after the war, my parents came back to England, and I started a little business. And that was my first taste of recording. We did, down in the west country of England, we recorded male voice choirs, Cornish brass bands, and music festivals and stuff of this sort, my partner and I. And of course, this was before the days of tape, if you can remember that. Anybody remember that? 78 RPM lacquer disc. And we had 2 cutters, and many's the time when we've gone in cold without any rehearsal to record something, an event that was taking place. And we had hoped, you know, a 12-inch record would give you 4.5 minutes. And we were just hoping that they would sing fast enough that they would finish the song before the cutter got into that white label in the center of the disc. You know, finger-biting stuff. But we learned a great deal, and we learned what was good and what was bad, and we learned how to evaluate sound, how to send sound from point A to point B, public address, sound reinforcement, and so on. All those things we just learned. So then I met the girl who was to become my wife, and she said, I mean, we had it all sewn up, and she said, you have to go and speak to my father. Now, she had grown up in India, the old British India, before the partition, before we were thrown out and the empire collapsed, you know. And she said, you have to speak to my father. He's kind of Victorian in his outlook, and he expects you to be very formal. So I went to him and I said, I want to marry your daughter, sir. So he says, well, you'll have to talk to her about that. I'm not going to influence her. I thought, you silly old so-and-so, we've got it all fixed, you know. I said, yes, sir, yes, sir. Well, actually, we have spoken about it. Oh, I see. So, well, he says, sit down. And I was sitting at one end of a big, long dining table, and he was sitting at the other end. And he said, what do you do for a living? I said, sound recording and public address. He says, what? Now, he'd been a principal of a big school in India, and he had never heard of sound recording, didn't know what it was, didn't want to know what it was. Public address? What does that mean? So after a few minutes, I gave up trying to explain to him what I was doing, and he came out with the big question. He said, are you going to be able to keep my daughter in the manner to which she is accustomed? Now, you just imagine that. It's a double-edged question, isn't it? Because if I said, oh, yeah, I was kind of insulting him because, you know, he was supposed to set the standard. And if I said no, well, I said no, sir, I really could not. You know, you've provided her with this wonderful home and all the rest of it, and so on. I can't aspire to that. Oh, so what are you going to do about it? Does your business pay you? Well, not really. And you know, I think most of us in the recording business could say the same thing. We do it because we love doing it rather than because we want to make a lot of money out of it. So I went off to London, a big city, and I got a job as a design engineer, now beginning to get on track. And then after I'd been there some time, one of the men there, who was the transformer designer for this group. This was Rediffusion, quite a big company, and a little bit like the BBC, very formal in their approach and very correct. And I learned a lot of disciplines when I was there. It was very good for me. And he came and he put a book on my desk, and he said, "You are now the transformer king for the company." He says, "I'm leaving." I said, "But I don't know anything about transformers." He said, "Well, that's all right." He said, "It's all in the book. You just read the book. It's okay." So I said, "Well, are you appointing me? Do I get a raise on this?" Or, no, transformer. And I soon discovered that the transformer designers were sort of not respected. They were kind of people who, they couldn't get anybody else to do it. And so they got the latest sucker to join the company to do it. But I learned a good deal about transformers, and that has stood me in very good stead. I had tuition, if you can call it that, from the suppliers of that company. Some of the great old names, which probably you wouldn't recognize today, but they were well known before the war for high-quality audio and transformers. Brian Savage, Norman Partridge, and people of this sort in England. And if you ever get to read any of these old journals, you can see the respect in which they were held. And I was able to get to know these people, and they were eager to teach me, so I learned. Well, we married and went from one job to another, but I was unqualified. And it soon became apparent that I was never really going to make it in a big company, because they wanted senior engineers who were qualified. It was quite difficult, just after the war, because all the men had gone off fighting, and those who came back usually could not go to university or college because they had other responsibilities and so on. There was an age thing which got in the way. And so there was really shortage of specialist engineering designers, which was really the only reason that I made it, because I knew something, but I wasn't qualified. And my wife and I talked about it often, and we said, it's going to be that if I was going to be the big fish, I would have to be the big fish in the little pond. I would never be the big fish in the big pond. And so we found a job which was a little pond, and that worked okay for a couple of years, and I was chief engineer, but the only engineer in this little company, manufacturing transformers, and again picked up a lot of knowledge there. And then we decided to start our own business. And so if you really need to be a big fish, you start your own business, because you're the only fish in a very little pond, and you can call yourself what you like. Manufactured hi-fi equipment, tape recorders, and things of this sort. It was all cutthroat business. It was all, hi-fi was well in advance here in the US. I'm talking about around about 1957, 58, 59. And it was kind of respectable and established. But if you talked hi-fi in England, very few people knew what you were talking about. And it really hadn't caught on. So for anybody to try and manufacture hi-fi equipment and sell it, you had a hard job. You had to try and show people why this equipment was more expensive than some little tabletop radio or other device that they could buy that was manufactured in quantity. And to kind of eke out our existence, I was also designing for other people. I designed carbon microphones for the Royal Air Force, and they are not hi-fi. But it was a challenge, and somewhere I still have a letter from a guy in the Royal Australian Air Force who told me that my microphone was the only one which could work at an altitude of 60,000 feet. Now, how he got to 60,000 feet, I have no idea, but my microphone worked there and others didn't, and that was good. We scored brownie points. So, came the day when I was always hankering to do something higher quality than carbon microphones, and I was visiting a London recording studio, talking to a friend of mine there, and along comes a gentleman who was into music concrete, and he wanted a simple little mixer which would take different input sources and mix them. You know, it was a very simple piece of equipment, but I built it for him, and bit by bit that started to catch on. Then I had contact with one of the London studios, Recorded Sound in Bryanston Street, and they wanted a 10-channel mixer with 2 outputs. It wasn't stereo, but it was a 10-channel mixer with 2 outputs. You could actually use it for stereo. And while this thing was kind of half designed and getting built, the guy calls me and he said, do you think we could get equalization onto some of those channels? You know, in those days, you didn't do that. Equalization was in a separate box, like a Pultec, something of that sort, which would be wheeled into the control room on a trolley, big chunky pieces of equipment, and by the time they'd patched it in and got it working, you know, at the most a studio would have 2 of these units, and so you'd have to decide where you were going to use them. And he said, could we get some EQ on each channel? Well, what kind of EQ do you want? So we just put some high and some low on it, and he liked it. And that was the first mixer that I think that anybody had really attempted to build, which had EQ built in on each channel. That was designed with valves, and you know, it performs quite well. In fact, AMS Neve, who inherited my old company, still have that mixer. I'm told they actually got it up and running at one time. So one of these days I'll have to go and check it out and see if they've got it right. But then came the day when Philips Records called me. They are now Polygram, or at least they were Polygram, and they wanted a mixing console, a portable mixing console, quite a substantial one. Discussed the spec with them, and when I told them that I could put EQ onto each one of these channels, and now this was not tubes, this was transistors. These were the new things, this was the new age. And I had been playing about with transistor amplifiers, again for the Royal Air Force, and I'd begun to learn about how to control these things, how to prevent them going into thermal runaway, how they could work under extreme conditions of heat and cold and so on. And so I designed this first mixer for Philips Records, and we used transformers, input transformers and output transformers, bus transformers, transformers everywhere, because it's the only really safe way of coupling 2 pieces of equipment together and totally liberating them from any common ground connections. Floating connections from one unit to the next unit. So you do not depend in any sense on ground, and there's no way in which any ground currents, be they hum or RF or lighting spikes or whatever, can get into your signal path. And we always were able to get a much purer and cleaner signal than anybody who wasn't using transformers. So that was the first one, and one led to another. We, by 1964, we were beginning to look at the possibility of really doing these mixing consoles, but I still didn't want to actually manufacture them. We were still getting other people to build the modules and the cards and so on. And it was hard to get people to work to the necessary standard. Printed circuit cards were totally new in those days and considered to be unreliable. And people would prefer point-to-point wiring and wiring harnesses and stuff on tag strips and, you know, the real old ways of doing things. But the printed circuit board was the way we had to go. And this particular console, I had a young man working with me from Pi in England, Pi, the Pi company, later became part of the Philips group. And he had been an apprentice, and he knew how things should be done. And he says, well, Mr. Neve, all these cards that we've got, they're just bare copper on the back. It's not protected in any way. That's not going to last. That's going to get, verdigris on it. It's going to corrode. And so we have to seal it. And we were due to deliver this mixing console within 2 or 3 days. We didn't have time to go in for any kind of fancy sealing processes. So he got on his bike and he went up to the village and he got one of these aerosols with a clear varnish. And we spread these out on newspaper on the floor and we varnished these. And you know, about 3 years ago, I saw one of those very early mixing consoles in Singapore. And they showed me this console, old black panels, and I put out my hand to stroke it because, you know, it was like one of my children or grandchildren by that time. And they said, don't touch, don't touch. What do you mean don't touch? Well, it's on air. It's on air, and I sold it to them in 1966. Isn't it time for a change? But why? Well, let's pause there for a moment, and this is very historical and probably very boring. Anybody got any questions, any kind of thing you'd like me to go forward on and talk about?
Really don't. Sounds interesting, actually.
Yeah.
It's fun.
Well, I warned you. This chair is creaking. Is that a nuisance to the recording?
We could switch you out to that one.
Well, it's okay by me, but let's do a
Let's
test.
see, I'll see who creaks more. This one's pretty quiet. I think we should give you this one.
Okay.
Let's do a switch here. There we go. We're going to do an upgrade very soon here. It's a software upgrade on the chairs.
Okay, great.
Do you remember what you sold that console for?
The Philips console?
Yeah, the ones in Singapore, is that?
Oh, yeah, the one in Singapore was quite a small, it was a little 10-into-2 mixer. And we probably sold that for a little bit under £2,000, which in those days would have made it about $5,000 or $6,000, something of that sort.
And the other console you said that was 2 out, was 10 in, 2 out?
Oh, the old valve?
No cans or anything like that on that?
No.
You said you could theoretically do some sort of stereo.
Yeah, it had the capability of 2 outputs, and but they were permanently assigned. We had 5 inputs going to one and 5 inputs going to the other, and so you can do it, but it's not the easiest way to do it. It wasn't really intended for stereo. Stereo was a relative newcomer, and there were these ugly rumors that in the United States people were using stereo, and nobody in England wanted to know about that. I mean, we hadn't got to mono hi-fi yet, and then we had 1958, we heard that the Decca Record Company were now doing all their master tapes in stereo, just in case it would ever catch on. And of course, you know, classic stereo, 2-track, is much more expensive than mono. And I'm not sure whether the Decca Company ever recouped what they did with those tapes. I'm sure they did, because stereo, I think, did catch on eventually. We then had the opportunity of quoting for a studio mixer for the Philips, well, it was part of the Philips Records company, their London studio. And the Dutch parent company stepped in. They had to get permission to spend this huge sum of money that we were charging. And I think we, if I remember rightly, this studio console, we priced that out at about, I think it was about £8,000. And that was a big fold-around console with a big patch bay with Tuchel-type connectors. I mean, they were basically continental in their origin. The ordinary tip ring and sleeve jacks were just not acceptable. So they did everything expensively. And that console had 3 outputs. And the reason it had 3 outputs is because Philips had just brought out a tape recorder which was 3-track on 1/2 inch. And this was their pride and joy. And they called it, you know, left, center, right, logically. And then they found that it wasn't a matter of perspective. The reason for the center track was that with the current lack of knowledge on stereo and miking, they had this hole in the middle. I mean, this was to do with the type of microphones, the microphone placement, and indeed with the monitor speakers. These things we hardly even think about these days. But there was a hole in the middle. And they said, if we put a center track in, I mean, we're coming right round to 5.1, aren't we? If we put a center track in, it's going to help that. So they put the center track in. But the guys in the studio very quickly found that they could use that center track to record something else on. So they'd take the band or the orchestra and they'd record left and right, and they'd leave the center track, and they'd then bring a soloist in who in London had probably finished work at a nightclub or something, and they could get him or her to come in the small hours of the morning and earn a few pounds, and they'd put that soloist on the center track. And it was the beginning of multi-track. So the next thing was that Ampex brought out a 4-track machine. And I can still hear people saying, 4 tracks? What in the world are we going to do with 4 tracks? So they called it L, C, R, and S. Left, center, right, and spare, because they didn't know what to do with it. They soon found things to do with it. And so we hastened to give our next console 4 outputs, 4 bus outputs. And so the track race developed. And I'm sure you're familiar with the way it went through 8 tracks, very briefly into 12 tracks. 16 hung around for a bit, 24 hung around a little bit further, and I had studio owners. This chair is still doing it. It must be me, I'm sorry. It's my old creaking joints that are doing it. So yeah, the sorry, I lost track of what I was saying.
Maintenance.
Yeah, I'll get maintenance on it.
You're saying you're going around to studios at that point?
Sorry.
You said you were going around to studios at that
Yeah.
point.
And there were two things in my mind, that we were designing consoles for people who knew what they wanted. Very different. I mean, yes, people do know what they want today, but we were about the only people who were able to design a console and tailor build it for a user. And there were some very fine engineers who would come and specify exactly what was wanted, and we'd spend hours going through all the features and facilities that were wanted on a console. And today it's different. Today you do much less of that. Today the client says, what have you got? What's in your catalog? What is standard? Because you could not today customize to that extent every console that you build. And so a console like the 9098 has to be almost all things to all men. It has to include a lot of features, some of which you would never use in any particular studio, right? But others of which would be used all the time. And that's to do with volume production. That's to do with the fact that to keep the price, I was going to say reasonable, a little less unreasonable, shall we say. We have to do it that way. We have to crank the handle on the production line and the consoles come spitting out the end, if you can believe that. The other thing that was on my mind was whether we were producing stuff which was paying for itself. Because I knew that once we'd finished supplying stuff to some enthusiasts in the London studios, you know, if that market dried up and we had no more enthusiasts, because these things were expensive, you know, I would have no livelihood. And I can remember going to Tom, I'm trying to remember his name. Anyway, he was the studio manager at Philips some months after the studio console was installed. And I said, you know, we charged this £8,000, this horrendous sum of money. And will you tell me frankly whether it's worth it, whether you'd do it again, and whether it paid for itself? And he just laughed. He said, it would have paid for itself at twice the price. He said it's almost completely amortized in less than a year by the saving in studio time. The reason was that all the older consoles, if you wanted to put EQ or any unit, any effects that there were in those days, insert that, it was a major operation. And it was tube stuff. The console wasn't, but everything else was. And it was unreliable. It needed to be warmed up. You needed to clean the connectors. You needed to mess around with it until you got it all working. And we do that even today, don't we, Joel? And so, huge amount of studio loss of time. And, but of course, if everything's built in, all you've got to do is to press the appropriate buttons and you've got your EQ, you've got everything there. And he was saying that on the basis of the features that we'd provided, the thing had paid for itself in saved time. And that was a great comfort to me. We had the television companies at that time in England used to get a franchise which went in 5-year segments, and they would compete to get and to pay the government to get a license. And so once they'd got this license, they would go out and buy some new equipment. They kind of refinanced, and they could do that. And by about 1967-68, we suddenly had a spate of these television companies coming to us, wanting to get the same sounds that you could get now in a recording studio. Because, you know, in video, audio is the poor relation. It tends to get forgotten all the time. And typically, the audio man is somewhere up 14 floors above the stage, and he needs a telescope to see down there what he's doing. And the console is some compact little thing, and he's in a little box, a little sweat box there. Audio isn't important, but what they wanted was the same performance as you could get in a recording studio, but in television. And of course, we were now into multitrack, but multitrack isn't for television. So at least it wasn't in those days. And you ended up with a mono output. And they wanted all these features, smaller, ending up in mono. And that kind of stretched things a bit, how to get this. Because what was happening was the pop groups, which had become popular, and to appear on television, they could not get the sound in the television studio associated with the record. So these guys were miming to their latest record, which brought in all kinds of problems, as you can imagine. How wonderful it would be if they could actually get that sound straight off the studio floor. So that was one of the things we could help them get. We supplied a number of consoles to people like Thames Television, and they called us in a panic one day, some weeks after a console had been installed, and they said, "There's something wrong with that Studio One console. It's fine when we start up, and the level gets lower and lower and lower and lower. Something is really wrong. We can't figure out what it is." And we went and looked, and the master output fader, remember this is mono, so there was one master output fader. Because everything was compact and crammed, there was no room for any additional faders in front of the operator. And this was in the upstand, and it was nearly vertical. So they started off with this fader at the top, and it wasn't quite stiff enough, and it would gradually be dropping, and they'd never noticed it. We had to go and fix it, so sort of things that happened.
I have a question.
Sure.
Were those early consoles, those broadcast consoles, were they actually called Rupert Neve consoles?
Oh, yes.
So your company was putting out those consoles were called Rupert Neve consoles?
Yes. In 1961, my wife Evelyn and I started the Neve company, the original Neve company, and that was Rupert Neve and Company. A year or two later, we incorporated, and it became Rupert Neve and Company Limited. And that went into the design and production of these consoles. And by 1968, we were selling £360,000 worth of product in that year. Now that, you can take roughly 3 times for the dollars of those days, and it doesn't sound like a huge thing. But bear in mind inflation, and you have to go at least 10 times to get the comparison. We were churning out consoles at an enormous rate. And we had bought in 1964, we had bought the old rectory at Little Shelford, a little village just south of Cambridge. And having had fights with the planning authorities who didn't want to see industry near Cambridge. That's a dirty word. We don't want our beautiful university environment and Cambridgeshire countryside polluted by industry. you know, they thought industry was something like some stinking chemical works belching smoke into the air and making horrible machining, grindy noises and things exploding and big trucks carrying stuff, and it was just going to ruin. And we could not explain to them that we couldn't get them to understand. Electronics are such a lovely, clean, interesting thing to do. And, well, we eventually got the permission and we landscaped the place, and anybody who ever went to that plant that we had just south of Cambridgeshire after we left the village will know how nicely we landscaped it and made it look right. And even the planners were comforted. But the these consoles, on the technical front, at this point, they were over-designed. We used large transistors. All the designs were single-sided. Do you know what I mean? The difference between a single-sided amplifier and a push-pull amplifier. A push-pull amplifier has two output devices which are fed in opposition, and then they combine together to give you the signal output. It's more efficient than single-sided. But by coupling them together, if you don't bias them correctly, the bit in the middle doesn't meet and it generates distortion. This was the problem with early transistor amplifiers. When in the mid-60s, the manufacturers of transistors, there were no ICs at that point, were trying to popularize transistors. And they would publish circuits in the journals, and they would sell kits which you could put together. And the big selling point was that you could get a 10-watt amplifier to run off flash lamp batteries because it was so efficient. It didn't draw any current, not until the signal level went up. And so everybody had fun doing this, but people began to say, well, it sounds different. It's not like our valve amplifiers. And there was one journal that wrote about this and said, we have just tested this amplifier. It's got this different sound about it. This is the new transistor sound. This is what we're going to have to get used to from now on. Well, I hastened to go and buy one of these kits and put it together. I was just horrified at the sound. Caused by crossover distortion, really bad crossover distortion. The lower the level, the worse it sounded. And I called the guy who had written about this, who I knew personally, and he said, well, that's what it does. That's what the design is. That's what we have to get used to. I said, no way, we're not going to get used to that. It's not music. It's horrible. It's producing high-order harmonics. And the higher the order the harmonic, the worse it is, even if the quantity of that harmonic is very, very small. So I stayed with my single-sided. If you have a single-sided amplifier, there's nothing to cross over. You don't get these high-order harmonics. You can get second harmonic, you can get third harmonic, and you usually get very little else. And because I really didn't know anything, I wasn't qualified, I just designed these things in fear and trembling, and so I over-designed. But it paid off because we were shipping these consoles all the way from people in northern Canada where they were left out in a station wagon in sub-freezing conditions and expected to work the next day, to the hottest desert points you can think of, where the ambient temperature was already putting any other piece of equipment using transistors into thermal runaway, and it wouldn't work. But ours worked, which was good from a reputation standpoint. So we had, up to about 1972, 72, 73 in that order, we were using these single-sided designs. And these are the classic old consoles which people rave about today. They're my worst enemies, We have to try and sell against those old consoles. And then in 1973, my wife had been a school teacher, and I'm an engineer. I hate trying to run businesses and fight bank managers and all this kind of thing. And we had reached a point where we had, I think it was about 360 or 380 employees at Melbourne. By the way, in the old rectory, where we had said we would never employ more than 3 people, when they finally kicked us out of that place, we had 33 people working there. And so even we realized we would have to build a factory. And within a very short space of time, we had this huge number of people. The business just zoomed up. And it was profitable, and it ran well. We had 135 people working up in Scotland at another plant up there. And we had, by 1973, we had 25 people working here in the US, sales and distribution and backup. It was really zooming along. And then a small public company approached us, and they said, it's successful and all that, but you're going to need capital for the next stage of expansion. We can provide that capital, and we can help you run this business. The old formula, our money and your brains. Well, I'm afraid they turned out not to have any money. I still have a few brains, but the equation didn't fit. If you ever hear that formula from a businessman, run, get out of his way. And console companies, high-tech companies, managed, populated by the people who founded them, the enthusiasts, the people who knew or thought they knew where they were going, you can't put a bunch of accountants in to run that sort of business. They just don't understand it. And so the Neve company started to be a little different after that takeover. And by 1979, although I had a non-competition agreement with them, I had really ceased to produce any useful thing. But the last thing I did for the Neve company was the 3 quite famous consoles which were designed for Air Studios, George Martin. We'd been supplying George for a number of years, and there came a point where they'd bought a new console. This was after I'd relinquished control. And Jeff Emmerich wasn't happy with it. And George called me and he said, we've asked the company's engineers to come and sort it out, and they can't sort it out. And, sometimes it's easy to be very cynical. But I knew that if Jeff Emmerich wasn't happy, there was something wrong with that console. Whereas some of the engineers who were there to check it went back and were asked, well, what was wrong with the console? Oh, there's nothing wrong with the console. We can't see anything wrong. Jeff Emmerich, he's mad. The customer's mad. How many times have you heard these rumblings from somebody who can't sort out some subtlety which you can hear and you know is right, and they can't get to the bottom of it? So finally, as I say, George Martin called me and he said, look, Jeff Emmerich is unhappy. When Jeff Emmerich is unhappy, we can't work. Can you make Jeff Emmerich happy? And we discovered that in that 48-channel console, there were 3 channels which the transformers had not been correctly terminated. And we measured and found that there was a 3 dB rise at 54 kilohertz. 54 kilohertz. How high can any of us hear normally? Not to 54 kilohertz. Not as sound coming in through the 2 holes in the side of your head. But Jeff could perceive something going on there. So a little bit later, discussion came up for supply of consoles to George Martin, who had started a new studio on the island of Montserrat in the Caribbean. And they had really come to the conclusion that the old company was now only going to give them older designs, and the quality wasn't quite as good as it was before, and they wanted something new. And they were really going to go away from us. It would have been damaging to us if they had done that, and I think possibly even damaging to them, because the whole character of a studio is determined by the console and the way the console is used. But I was able to persuade George. We were called into a conference, and they were very politely telling us that they wanted to make a change. And I can't remember exactly how the thing cropped up, but George said, I think, unless there's something you can do for us, Rupert. I said, well, yes, what you want, George, is the best console in the world. And you're about the only people who can afford to buy the best console in the world. It's going to cost you quite a lot of money. And he said, well, yes, I understand that. And as he'd had lunch with me a few weeks before and told me that his biggest problem in life was losing £2 million a year, so he didn't have to pay the tax man, I felt that I was justified in helping him towards that end. And he said, what can you do? I said, look, before we even talk about that, I've been in your studios recently, and there's all kinds of things wrong. For one thing, they had daisy-chained all the mic lines around the 4 control rooms, and so wherever you plugged a microphone in, there was a huge amount of capacitance, cable capacitance, hanging on that microphone. And I said, microphones are not designed to be sort of line-driving amplifiers. And when you add that amount of cable on, that's going to mess up your sound. And I had been checking some tape machines and so on, and I found heads out of alignment and all that kind of thing. And I said, George, there's no point in my doing a super console for you if you don't clean up your act in the studio. It was a very arrogant thing for me to say. But he said, oh, great. He said, now, fine. Have you got time to come and have a spot of lunch and we can talk this thing over? And we had a sales director who was in on this interview, and he was a fussy little man. He was a very good sales director, by the way, but he had his notepad and his pen out. He wanted to get signatures and orders and things. He was a real guy, wanted to sell the thing. This thing was not defined, and he said to me, does that mean we've got an order? So I said, well, shut up, Derek, and go home. George and I are going to sort this out. And yes, we had a verbal order, and at that point, I really wasn't quite sure what we were going to do for him. But in the next few weeks, the whole of the console was redefined. New types of toroidal output transformers, input transformers, new circuitry, the whole thing. And with a colleague of mine, we did the whole of that design in about 6 weeks. And then, because there was a tight time frame on the delivery of the first of these consoles, the company put all its best people on. We had the best wiring team, and they'd carefully reserved the right amount of time in the test room and so on. And one of the things that I was insisting on was that we had a very wide bandwidth. I didn't know how wide it had to be, but it had to be a lot wider than the original consoles. And so we actually ended up with a console which went out to 0.5 megahertz in bandwidth, and it would maintain that at not at full output, but at plus 10 dBu output, right up to 0.5 megahertz. And my then chief engineer came back to me after having done some tests on this console, and he says, Rupert, do you really think we need to go that far? it's going to produce some other problems if we let that go out into the big world outside. So we restricted it, we compromised, and we said 200 kilohertz is okay. And we've stuck to that ever since. Joel's console here will measure out 3 dB point is just around the 200 kilohertz. And that's one of the factors that make it sound the way it does. So, I don't know whether you'd like me to go into more of the technical things or, yeah.
I have a quick question.
Push-pull output stage, which was smaller and more efficient. And I finally let the lab convince me that it was going to perform as well. I never think it performed quite as well, but consoles were becoming more and more complex. We had to package more and more into them. And for the first time, we started running into packaging problems and heat problems, which we'd never encountered before. Then we were moving over towards the use of integrated circuits. Now, integrated circuits were a new thing, and up to about 1972, 73, thereabouts, the kind of integrated circuit which was available was a 741, a general purpose, useful workhorse, and you can still buy it. Much improved over its original form, I might say. But for high quality audio, it just wasn't usable. And there was always, because the company was now run by accountants, they were always looking for some cheaper way of doing it. Can't you use these integrated circuits? You know, it's so much cheaper. Yeah, but cheapness doesn't produce the sound. And we were constantly having this kind of fight with them. And then came a point where the Philips company in Holland approached us, and or they approached the new owners of the company, I should say. And the new owners were very flattered by this. Philips want to find out about our technical stuff. They want kind of technical cooperation program. Well, I'm an old cynic, and I knew what these guys were after. And what for? Oh, it would be such an honor to have Philips come and, find out what we're doing. And I said, no, they just want to find out what we're doing, so they can do it. They had been producing consoles until fairly recently, and I knew some of the people over there. They were good people, but they too had commercial bosses. And so finally the new owners prevailed, and they said that we are going to talk to the Philips people. And they pulled out all the drawings of all these schematics and stuff which the company was using, mostly based on my design still. And the Philips people took these drawings with them, and they said quite openly what they wanted to do was to find out what was in what they called this operational amplifier, an op-amp. Today we think of an op-amp as an integrated circuit, but the form of an op-amp isn't necessarily an integrated circuit. It can be discrete, and that was the discrete circuit that they wanted. Now, they could have gone out and bought stuff that we'd manufactured, and they could have reverse engineered it. They could have found out how it was done. But, the stupid new owners just gave it to them. And so eventually they furnished us with some prototype integrated circuits. And they were very good. They were better than the circuits I'd been using, because when you're like Philips, Signetics, or any of the major manufacturers, you can actually design the semiconductors that you need. All those little chip things can be designed specifically to put together. You don't have to thumb through catalogs and find something that might be appropriate for your circuit. They can just make what they need. And they had made a very good integrated circuit, based, maybe loosely based, but it was based on my little op-amp. And but of course, what was happening then, they produced some prototypes. This was the TDA 1034, as they called it, and that was later rebadged as the NE 5534, which we're all familiar with today. And they were going around to all the other audio manufacturers, and they're saying, try this new IC. And they were all saying, wow, this is good. But, you know, we'd handed all our competitors this information via Philips. That's what an integrated circuit does. It's cheap, everybody buys it. And if it's good, whoever started it no longer has the unique use of it. So that then led to other problems, because there was a huge demand for it industry-wise. And they were making this thing in Switzerland in really a pilot plant that they had. And we suddenly had our purchasing people say, we can't buy this thing. Now we're committed to building consoles with it, we can't buy it. And I had to go to Holland and negotiate with the people there. Bear in mind, I was not then in charge of the company, but they did listen to me, and they finally got us enough to keep the wheels turning. And then they undertook that they would they'd move the production across here to California to the Signetics plant. And once they got that going, then there was no longer any problem with the supply. So that's how integrated circuits got into the consoles.
Was that the Siemens company? Was that the Siemens company that was your owners at that point?
No, that was a little British public company, much, much smaller than Siemens, and this was called Energy Services and Electronics. At that time, the oil business in the North Sea had become big headlines, a bit like the internet, you know, and everybody was scrambling to get a foothold into something to do with oil services in the North Sea. And, well, they overreached themselves and they ran out of money, and as a lot of people did, and it's somewhat parallel to the internet stories today. So they overshot themselves, and we suffered as a consequence, because instead of making capital available to us, you know, our money and your brains, they were actually doing the opposite. They were milking the company of everything it had got to pay bills for other companies that were in a bad way. So that didn't work out too well for us. But, I mean, that's another story. I'm no businessman, is all you can say. Well, the Siemens company kind of rescued them. One of the problems was that there was a new technical director, and he convinced these accountancy gentlemen who were running the company that they should not manufacture anything more analog. This was 1978 or thereabouts, and that tomorrow everything would be digital. And he was working on some digital designs, and within 18 months it would be all digital, and we would be first in the field with digital consoles. Well, anybody who has any memory of how difficult it was to get anything digital to work at all until reasonably recent, certainly not in the early 80s and late 70s, will know how wrong that gentleman was. In 1982, I still had this non-competition agreement with the company. They called me and they said, Rupert, we desperately need new product. We don't have anything to sell. We've ceased all the analog production, and except for one or two of the broadcast consoles, and we haven't got anything digital that works. Can you help? So I talked to them, and of course they had still some very good engineers, people who had worked with me in the past, and I could claim that I'd trained them. I said, you've got these good guys. Why are you talking to me? And that was they did produce a console, and I had nothing to do with the actual design of that console, but I can say that I encouraged the new owners that they should use the engineers they'd got. And that was the beginning of the V-series consoles with the Neve company. They were different to the ones I'd used. They were more efficient. They had a different type of sound path, and exactly. In fact, the engineer who led the design of the V console, his name was Dave Pope, a very good designer. He's still a consultant in the Cambridge area right now. And so they jokingly called this the Vatican console because his name was Pope. And then when it came to market, of course, they couldn't put it out as the Vatican, so they just called it the V series.
Do you need a short break here, Rupert?
Probably you do.
Not at all. I think everybody's really enjoying the history.
My wife had asked me to tell you a story. Maybe this would be a good time to do it. In 1989, we had started a small record company in the city. And one of the guys who worked for us as an accounting clerk was a musician, and we were his day job. And he had saved up his money, and he and his band finally were going to get a chance to go into the big local studio. I think it was one of the old Wally Hyder rooms, to cut an album. It so happens that the day that they were mixing the record was the day of the Loma Prieta earthquake in 1989. And at the time that they were in the studio was the exact time the earthquake hit. And this guy, his response to it was to dive under the console. And when he came back, he was telling one of the other guys that worked for us about this experience. And the guy he was telling it to said, "Why did you dive under the console?" And he looked at him and said, "Dude, it was a Neve."
Built to last.
Unfortunately, they do last, and and we have the classic situation. Well, it's not a classic. Whoever, after 25 or 30 years, finds himself competing with himself.
Planned obsolescence.
Well, and the Neve company now is making copies of those old designs, right?
Yeah.
The new console.
Yeah.
So it's come back around.
It's come back around, and it's very interesting because all those old designs had a particular sound about them. What we're doing now is pure path, which there is no actual sound associated with it. It's a wide open window. It is as free of distortion and noise as we can possibly make it. Its performance is way, way, way better than those old consoles. And I'll go more into that, if you like, as we go along. But the point is that if you need the old sound, you can always get a few old modules and feed through the signal through. And a pure path console or other device will not add any coloring that you don't want. The old consoles, you buy an old console and you've got that sound, and it may be wonderful, but you're stuck with it. You can't back out of it. So with things improving, we are now getting to the point where digital standards are improving enormously. We've already got DVD. 96 kilohertz sampling and a higher bit rate. And I've been blowing a big trumpet to go even further, to get a 192 kilohertz, and that's coming. The chip companies keep coming to me and say, try this, try that, and it's getting there. It is going to be nearly as good as analog within the next 2 or 3 years. Now, I'm not being facetious when I say that, because the dynamic range that I can get from the best of the chips that have been offered to me on a basis of analog in, analog out, and the A to D and the D to A converters in the middle, so no other processing, I can get a dynamic range which is somewhere between 110 dB and 120 dB, depending on whose chip it is and one or two other things, and which day of the week it is, and which way the wind's blowing, because these things are not as exact as the digital people would like to have you think. It should be absolutely pristine, exact, but it's not. Analog, you can measure this console under the same conditions, line in, line out, and you will find that there's a dynamic range of 126 dB. So we're still at least 6 dB better in dynamic range than anything that is yet possible in the digital domain. If you're going to feed a digital recorder, what do you have to do? Can you feed it at plus 26? You have to throw away 10 dB of the headroom which I have thoughtfully and lovingly provided you with over the years, because the digital guys can't take it.
Is that because of the sampling rate? Is that the sampling rate problem?
No, that's the bits. As I understand it, I'm not a digital designer, but as I understand it, the bit rate is pretty much governs the signal to noise or the dynamic range, and the sampling rate would cover the frequency range. So in order to get a 100 kilohertz bandwidth, you've got to have a 192 kilohertz sampling rate. And it's been done. I mean, it's there on the design bench, there's no problem. But to make it commercial and affordable hasn't yet been done. But I think the point that I'm making here is that we are now, as an industry, looking at the next stage, which is higher quality. We're going to surround sound, multi-channel. People are expected to pay a lot of money for these things. And we as an industry are recording and creating signals which will fit these systems. And they had better be good, both technically and from the point of view of what we do in the control room. It wasn't that long ago when I was in a studio and they were showing me all the wonderful things they were doing, and they said, listen to this that we recorded last week. And what can you say? You have to be polite, don't you, and be very cautious in your criticism anyway. And so I just moved my head back and forth, and I could hear 3 sweet spots. So I started to feel indignant, because these people thought that this was pretty good stuff. I mean, it sounded fine, but it wasn't stereo. I said, have you ever thought of recording stereo? But this is stereo. I said, no, it's not. It's panned mono. 3 different sweet spots. You've got mono sources, and you just put them here, here, and here. That's not stereo. And when it comes to surround systems, that is not going to work. Once we have advanced beyond the point where the demo stuff, the car chases and the bombs going off and all the whiz-bangs and all the dramatic stuff has gone, and we actually sit down to listen to the things that we enjoy listening to, what we should be able to get is a total experience, not just listening to music, or we ought to be able to go into the concert hall, go into the little nightclub, or whatever it is, and you guys have to create that sound environment. And unless you are doing it with true stereo techniques, it's not going to work. and it'll fizzle like some of the old, things like SQ and QS and these 4-speaker systems of the past and all that sort of thing. They came and they went because it didn't really work. We have to make it work. We have to understand the techniques that are required. It may mean doing a lot of thinking, a lot of learning, a lot of experimentation, burning up of time. But we need to be able to deliver to our clients that experience so that in the home you're transporting them into the environment that you want them to be transported into. If we don't do that, we're not going to succeed. Combination of high-quality digital, and we have to have high-quality analog to get into the system. We have to have high-quality analog to get out of the system. If you show me that we need more dynamic range, I can give you more dynamic range. At the moment, we've given you 10, 16 dB more than you can possibly use. And but we're working on it. One day digital will give us more. 24-bit, the basic norm is 6 dB per bit. 24-bit is 144 dB of dynamic range. And somebody said to me several years ago now, oh, digital is 144 dB of dynamic range. No, it isn't, because a 24-bit does not automatically give you that. It's diminishing returns. It just doesn't cut it yet, but it will do. And before it does that, I'm going to stay a jump ahead. So they'll give you another bit of actual dynamic range. I'll give you 2 more bits equivalent in terms when you show me that you can really use it. So we shooting a line, but basically it's all about values, and values are really what creative people are about. We start where I started talking to you, with values which are conditioned by your background, your experience, your upbringing, your education, all these things, and your aspirations. What you want to do is all part of your value system. And then we go on into, we can say that's creativity. And, I often reflect on how fortunate we are in this industry, where we can do what we like doing for the most part. It's very satisfying when you've got some good sounds and you've done something that sounds great and people compliment you on it. There's a sense of achievement, a sense of fulfillment. But 3/4 of the world does not have that possibility. There are massive numbers of the poor, if you like, in quotes, the poor, who spend their lives just looking through the garbage cans to try and find some food for the kids, wandering the streets trying to find a place to shelter for the night, and so on and so forth. They're human beings. There's the same spread of human qualities and values that they have buried inside them. They have no fulfillment. They can't do what we're doing. We can have fun, we can be fulfilled. We have our problems, yes, but we don't have their problems. I reflect on this because I like to try and philosophize. Where do we come from? Why do we do it? What we do is the creativity which is created into us by the Creator himself. We are created in the image of God, and he is the Creator. If we're in his image, then we too are creators. And let us just remember those things, and remember that every time you put music onto disc or tape or whatever, you have done something which millions around the world would just love to be able to do and learn how to do it. I don't know what that means. I'm not suggesting that you bring the poor into the studio and teach them how to do it. Just keep your eye open for some means of helping, and we're looking at Christmas coming up in a few days. There are many organizations that are out there with the begging bowls to do good works in this country and other countries. Just remember that at Christmas time. Think of it. These people are creative people as we are, but they don't have the opportunity. And you know, I very much respect the people that go out and actually help them. It's no good just giving them money, but money is a good starting point. So, the old Chinese proverb, you give a man a fish, you've given him a meal for the day. You teach him how to fish, and he's now able to support himself. And one of my things that I like to do is to be involved with organizations that teach people how to fish and help them along. I could even go as far as to say that when you buy a console from AMEC of my design, I get something out of that. And so, you know, that's a way. And I said, well, we're not making consoles. Oh, well, supposing I were to buy one of your old consoles of this type, and I have the opportunity of buying another type of the other type, and I can kind of knit them together and make a big console out of them. So I said, no, you can't do that because they're different types, they won't fit, you know. So the engineer in me started to react. Oh, I said, well, how should I do that then? And so within a few hours, I was saying, you know, Steve, you can't really do this, and you're still, the same message, you're still stuck with the old sound, and you really need to do something better than that. Oh, how would I do that? And I found myself saying, well, let me build it for you. We had, I mean, this is sort of exposing the whole thing. Focusrite was doing well with the modules, and we sold, sight unseen, 8 major consoles like yours. And it was a very simple logic thing. There was no recall on it, and there were a lot of things that you got which were not on these consoles. But there was a logic control system, and I'm not a digital designer. And I had a young man who came out of one of the government departments, and he'd been designing flight simulators and stuff which sounded much more complex than a console. And he just looked at what had to be done. He said, oh, no problem. He said, this is easy. He said, I can do all this in 6 months. Well, the long and short of it was that we had constructed most of these 8 consoles. The analog stuff was done, frameworks were done, and they were just waiting for the logic cards to go in. And the logic cards never came. We were stuck with a classic situation. We could not ship these to customers. We couldn't get paid for them. Customers were screaming at us, rightly, and we had no cash flow. But we had suppliers. We'd bought all these parts, and they were either in the consoles or on the shelf waiting to go into the next console. Huge cash flow situation. And the long and short of it was that the banks wouldn't wait, and they put us into liquidation. We had a number of people who were interested in buying Focusrite Limited, but it never actually happened for various reasons. You know, when a company goes bust, very few people want to just continue to run it unless they fully understand the reasons that it went down and they could put that right. They'll wait until it's really gone into liquidation, and then they'll make some small offer to the liquidator. Well, Phil Dudderidge, who had been one of the owners of Soundcraft, was one of the people who had been talking to us about buying the company. And everybody else had walked away from it and waited for it to go down, and so did Phil. But he finally paid the liquidator for it, and he asked me if I would work for him, and we couldn't agree on terms, and so I didn't work for him. In the meantime, Nick Franks of AMEC, who had also been looking at us from the point of view of possibly buying the remnants of Focusrite, wrote me a wonderful letter. He had totally understood and envisioned my situation. We had personal debts up to here. We nearly lost our home and all the rest of it. And Nick said, I will pay you this, that, and the other. I will do, he made me a wonderful set of offers, and I will take care of these debts. You know, there was the car, there was the copying machine, there was Tesla, there was everything we had personally guaranteed. He said, I'll take them all over and get you off the hook. I would like you to come, and if you ever have the opportunity, he said, to come and work with AMEC, and to bring AMEC into the realm of performance of your old original Neve company. So we talked with him, and he was totally generous. And this is Nick is an amazing person. He and Graham Langley were the owners of AMEC, and it was a good combination. Nick had a tremendous vision, but he was very difficult to work with sometimes, and yet he was very generous. He had a heart of gold. Once he'd given a word on something, he would never back out of that. Absolute integrity, beyond the norm. So I went to work for AMEC as a consultant, and asked Nick, what do you want me to do? He said, well, apart from what we want you to do for the company, we want you to design and build the best console that there ever has been and ever will be. Well, ever will be is too much, but... Okay. And, well, you heard him say that, so...
I'll let you know.
So I started working on the 9098 at quite an early point in that relationship. And we did some modules and we did some amplifiers, and I now had the leisure to do the things that I hadn't been able to complete at Focusrite, and I would like to have done more at Neve, although that was a bit further back. So the 9098 embodied some design features which were really beyond those which I could have done just on my own. With the backing of AMEC, I was able to do that. And the 9098 console, we developed a new microphone preamp. Microphone preamps are probably one of the most important parts of any console. It's where what you do in the studio interfaces with the electrical system. And a huge amount of study went into this. My Focusrite designs used transformer inputs for the mic pre's. I used a transformer which I had not designed myself, but which came from Lundahl in Sweden. It's a very expensive transformer. It's a very good transformer, and I had concluded that it was most unlikely that I would beat Mr. Lundahl at that game. He's a very gifted designer. He and I would have telephone conversations, and I'd say, I want a transformer to do this, this, and this. And he says, that's impossible. No, it isn't, Mr. Lundahl. I have one on the bench. I have a prototype which I've wound myself. How did you do that? So we'd discuss it. Oh, well, okay, if you want to do that, you're okay. Well, yeah, we can have a go at that. And he would then sample me a few days later. But on the output transformers, they were my design. The input transformers were his design. And so the transformer, though, the input transformer is always much more difficult to design than the output transformer. Distortion at low frequencies in a transformer is directly proportional to the voltage input to that transformer and inversely proportional to the frequency. So if you establish that you need a given percentage of, you don't want it to go beyond a given percentage of distortion and a given size, you've got the option of saying this transformer will go down to, let us say, 20 hertz, but it will only handle minus 20 dBu. If you go up 6 dB, doubling the voltage, then it'll do the same distortion, but now at 40 hertz. It's a sliding scale. It's a value judgment. It is a value judgment, not just an engineering judgment. Where am I going to sit that performance so that you guys don't know there's distortion there? And so it was a compromise. That's what led to the new amplifier design without a transformer. But we had to have it behave like a transformer because, as I've often said, the transformer is probably still the finest way of connecting two pieces of equipment together. Totally free of ground currents, hum, RF problems, and so on. You can do what you like, pretty much, connecting transformer equipments together. And how to do this without a transformer? So I designed this transformer-like amplifier, which has a very, very high impedance between each of the two input ports and ground. We tie these together with a resistor, typically on a line input or the mic input itself. It has a 10,000 ohm input impedance. Now, with a transformer, if you feed a signal between ground and one leg and leave the other leg open, you're not going to get any output from it. You have to have a voltage across that primary So a current flows through that primary, and a voltage is then induced in the secondary. The big thing about a transformer is that you can easily balance it, and so any common mode signals that come in are automatically cancelled by its common mode rejection. It's also a low-pass filter. You can design it for the bandwidth that you require, and frequencies above that point will not get through the transformer. It's a beautiful way to do things, but it does have that problem that an input transformer, you don't have any control over the outside equipment that's feeding it, and it does have a limitation on the levels. So the TLA was born. It behaves very much like a transformer. If you feed a signal between ground and one leg and leave the other open, what happens is that 10,000 ohm resistor feeds the other leg in common mode. There's very little voltage dividing action, and so the natural common mode rejection of the amplifier that follows takes over, and you get no output. I could go on about this, but that's the principle. We also used a coil, a common mode coil, to replace the filtering effect of the transformer at high frequencies. So that works extremely well. We can get a full plus 26 dBu input right the way from 20 hertz or below right up to very high frequencies. We don't have the limitation of the transformer there. It's just a crystal clear path. The output stage is much easier because the output stage is under the control of an amplifier, a driving amplifier, and we use a tertiary winding within the feedback loop, and the distortion is very low. The performance is very good, and we have this toroidal transformer, which will drive long lines without any problem. You're not into balance and grounding problems. So a combination of these two techniques, input, TLA, and the output transformer, is what we've done. I talked about Class B and push-pull amplifiers earlier on. An integrated circuit is a push-pull amplifier. There are very few exceptions to this. There are one or two which have a beautiful performance, but they don't have much driving power. And so we use power output transistors to build up their power. So by a combination of discrete transistors and choosing the best ICs, we get a performance which is superb. We've carried that even further in the new pure path range. And the sensitivity of the informed person is such that we can perceive distortion products, particularly the higher distortion products, that are more than 100 dB down, 110, even 120, depending upon the actual order of the harmonic. So we've eliminated that entirely. I could show you, I've got them on transparencies unfortunately, but I can show you the FFTs which show you the actual magnitude of each of the harmonics, and how in some of the older designs those harmonics are present. In some designs by another, the guy down the road, they are much higher, and in the pure path they're right down pretty much as good as the audio precision test gear can give us, right down to 140, 135 dBu. And it does make a difference. The problem, of course, is finding anything else which is as good. Every microphone has a microphone amplifier. I can't find any microphones which have inbuilt amplifiers which don't give you some of these harmonics. But let's get our side of the thing right. So the pure path. Your console is almost pure path. It was the one, so, don't wait 10 years. We'll sell you one in 5, which will be...
Modification time?
Yeah, version 2.0.
And PurePath is the new gear that has come out in the channel.
Yes. This is a new range of modules which embodies these techniques, and I'd be interested in getting some feedback on what people think, comparing, for instance, with the 9098 equalizer, with the new CIB, and a number of people have already commented on it, unasked. There is a difference that the informed listener can identify.
Well, Rupert, I'd like to thank you. I think we've covered a lot of the information that everybody wanted to hear. And, anybody have any last questions that you might want to ask Rupert in regards to the console or anything else? No, see, I think you've educated them to their fullest ability tonight, Rupert.
Can I ask one?
Yes, absolutely.
I was just interested, you touched upon the idea of a stereo sound field not being used properly. And I wonder if you'd expand on that, just for a moment.
Just for a moment, okay.
A lot of debate there.
Well, in this room, what can we hear?
Air conditioning just kicked in.
Yeah. And we can hear people, body movements, clothing movements, breathing, little mouth movements and so on. And, if you shut your eyes and listen, there's a huge amount of information which we normally would disregard. Well, we try and disregard some of the things that we don't want to listen to. And if we, I like listening to English cathedral church music, this type of thing, choral work, and that is accompanied usually in the environment of a long reverberation time. And at quite an early point, I listened in many different locations, and you can find places which have the reverberation peaks up at some particular frequency, and then you go to another place which looks pretty much the same, but the reverberation is different. And then you can take the kind of English church or college chapel or small cathedral, which is generally built with a softish sandstone, and that will produce a different sound to that which you'd encounter with the same choir on their visit to Italy or Spain, where they're encountering hard surfaces, marble, very hard building surfaces. It's different. It's not a question of which is better, but it's different. And I got to thinking, well, how can you actually convey that environment as an experience into the listener's home? I mean, just 2-channel stereo properly done is absolutely amazing. You can do it. And the dear old BBC in years gone by had a huge aficionado audience for a weekly program, Choral Evensong, from a famous cathedral or a famous place of this kind. And there were engineers who just spent their lives doing this. It was a once a week thing, and they'd make a big thing of it, as an outside broadcast or remote, which took a huge amount of setting up, a huge amount of rehearsal. And they would take a microphone down to the other end, and they would just point it at a piece of soft stone to get that sound off that stone. And they'd mix it in. They might feel that they had to close mic it rather closer than they would like to for other reasons, but they'd have the microphone pointing at the soft stone to get the character of that. All right, you say that's an artificial experience. It's not really, because we have to use our knowledge of how to do these things to get that experience into the home of the listener. And it was just hugely successful. It was such a lovely thing to listen to. It brought this huge sound stage into a small room and made it sound like a huge room. I think that's what we have to do. But you can do this in a small nightclub. You can almost smell the smoke and the beer and so on if you get the acoustics right.
Bob?
This is sort of the classic question. How do you combine 60 or 80 channels together and keep 120 dB dynamic range?
With difficulty. If you, how can I put this? Of course, every time you double the number of sources, you're worsening your dynamic range by 3 dB, if it's just noise that we're talking about. But you're not only listening to background noise, you're listening to signals coming through these channels. So the signals that build up to a higher value than the noise does. There's a lot of coherence in that. Every time you add coherent signals, you're gaining over the noise background. And from a design philosophy point of view, I ensure that the bus noise is way below anything that is coming off the channels. The actual input channels are the predominant noise source in the console. Everything else is just right out of the picture. Every time you add a sound source, you are worsening the dynamic range in respect to the noise, but you're also adding a lot of signal in there, so you're backing your gain down to cope with that. And the effective dynamic range is not that different from the one-channel situation. You have to also remember that it's not only the console that's causing noise. There's the microphone amplifier itself. You read the spec of the microphone manufacturer, and they have improved enormously, even in quite recent years. Even 5 or 6 years ago, it was hard to find a really high-quality microphone with a self-noise which was better than equivalent noise of 20 dB of sound pressure level. Now they've got it right down. It's gone down to 16 dB to 14 dB, and there are one or two. There's the new Sennheiser, which I think is quoting 9 dB of self-noise. And I mean, that is a lovely microphone amplifier in there. I must get to look at the schematics sometime, see how they've done that. It's beautiful. Then you've got the studio itself. You can get, well, if you could get a noise-free microphone and a noise-free input channel, is your studio going to be noise-free? What is the actual noise rating of your studio? A really high-quality drama studio is going to have an NC value of what, 15, 18 dB? But not many of our studios are anywhere near that because it costs money. The things that make for silence are massive walls or super stiff walls and distance. So you can either go out into the desert away from every noise there is and record in virtual silence, or you can spend megabucks on creating isolation in your studio. And it's diminishing returns. For every doubling of mass of a wall, you get a 5 dB improvement in isolation. You know, where do you stop doing the arithmetic? But noise is there everywhere. And of course, the same will apply to digital, because you are actually starting with analog noise. Even if everything else was perfect, you're adding sources from the studio noise. Physical limitation.
Thank you.
Well, thank you very much for listening.
If any of you would like to adjourn to the control room to see the console, you're more than welcome to, and there are refreshments upstairs. If anybody would like a libation, I'm sure Rupert probably needs one right there.
Right now.